There we go. Sorry, guys. Okay. There you all are. Okay. Okay, so what I was saying when I was not presenting is that we're going to study exponential functions today. And I know that in high school you've been exposed to this before, but 2 is of course the base. The thing that makes this a exponential equation in the first place is that the variable is the exponent. Okay. What else I want to tell you that? Okay, so what's important here? Let's see. This is the function where the power is the variable and it's called an exponential, and obviously the number 2 is called the base. All right, exponential functions take this form, k times a to the x, where a is a positive constant. So let's write that a little bit bigger too. So we've got f of x is equal to k times a to the x power. So the a value is a positive constant. What does it mean when it says it's a positive constant? What does that mean, constant? It means it's a number, okay? Positive constant. So it's a number. Okay, now when we're doing exponential functions, there's 2 things that you need to keep in mind. And that is if something is increasing, it's called, it's growing, right? If something is decreasing, it's decay and it's decreasing. So in all of these formulas that we're going to do today, you have to ask yourself, is this a decreasing function or is this an increasing function? Now, in order to find the growth rate, you're going to use whatever your a value is minus 1. If you want your decay rate, you have to do something different. You want to do 1 minus a. And that may seem kind of out of context, like where is she getting this a or whatever. But when you look back at your notes and you start to do your Wiley homework, that's the first thing I want you to see, because that's where you will make your mistakes. Okay, so this ends up being really important. The rest of it is pretty simple. Okay, so let's do an example. Okay, so the population growth. The population of Burkina Faso, a sub-Saharan African country, from 2007 to 2013 is given in this table. To see how the population is growing, we're going to look at the increase in population in the 3rd column. So this is if the population had been growing linearly, this number right here, this 3rd column, right, change in population, would be the same number. For example, let's say 0.5 million every year. So we know it's not linear, right, because of the change in values are not constant. So although I'm going to write this, I should have wrote this ahead of time, but I'm going to just write this because this is important. Although change is not linear, here we do have a constant percent change. And another way of saying that is percentage change, change meaning the little triangle. Okay, so actually, let's get the order right. Okay, so if we're looking at the percentage change in those two numbers, we would take, let's see, where do I want to write this? Down here. We would take the 2008 population number and divide it by the 2007 population number. So those numbers are 14.660 and 14.235. And if you get those numbers, you're going to get 1.03 if I round it. Now, technically, you're actually going to get 1.0298. But I'm just rounding that to two places, okay? All right, let's do it again. Let's say now we're going to go from 2009 to 2008. So now we're going to go these two to see what percentage change it is. So we have, just like we did before, the 2009 population divided by the 2008 population. And you get these numbers, 15.095 divided by 14.660. Put those in your calculator and you're going to get, when you round to two decimal places, 1.03. When actually, you actually get 1.0296. So although these numbers right here, these two numbers are not exactly the same, they're the same enough, right? Like when you round them both to the second place, to the 100th place, they are the same, and it's same enough, the same enough to follow a particular pattern. So you can say, yeah, that's close enough, right? To say this is exponential. All right, so what do we get here? So 1.03, and remember I told you what's happening here from 2000 to 2008. Is it increasing or is it decreasing?
Increasing.
Yeah, definitely, right? Look, it went from 14 point something million to 16 point something million. So it's continually increasing. So it's important to know this is an increasing function because, like I said up here, in order to find the growth rate, you're going to take your A value and subtract 1. So our A value here, what we just did, and I should tell you, what we're doing here is finding your A value in both cases. So in order to find the growth rate, since we know that this is a increasing function, you're going to take 1.03 and subtract 1. So you just get 0.03, which makes sense, right? Because 1.03 as a percentage is 103%. So doesn't it make sense that it grew by 3%? I'm giving you this formula for a reason, though. So that when, one second, Jadel, I'm giving you this formula because when we get to decay, it's not quite as intuitive. So you have to use the equation that I gave you, or the formula backwards, and I'll show you that in a second. Go ahead, Jadel.
Is the formula, is it just the f of x equals k times a raised to the x power?
This right here?
Yeah, is that the formula that you want us to use?
It is. And you'll see we're going to be using it over and over again.
Okay, thank you.
You're welcome. So 0.03 is 3% growth. Okay, so that's kind of an example of the real question is, how do we know this is exponential based on this data? Well, we know it's exponential because it has a constant percentage change, or A value, right? Or growth rate here. Okay, so let me tell you, this is the formula, right? For our set of data, since we're talking about population in terms of time, I'm going to use those letters, okay? And the constant is always going to be your initial, oh, let me write this better so that it's legible for people that are not here. So this is your initial population. Then our initial population was what? You guys tell me. Jadelle, if you're trying to speak, you're muted.
Oh, 14.235.
Yeah, I thought that's what you were saying. Yeah, it's the initial amount, right? The smallest number on our chart is our initial amount. So we're going to put that here, 14.235. What's our A value? Anybody know what the A value is for this set of data?
1.03.
Yeah, it's the growth rate. And T is since it's P of T, right? It's population in terms of time, then there's what we did is we just wrote an equation, an exponential equation based on that set of data. So if I gave you a set of data like this, could you figure out the growth rate? Yes? You guys don't seem sure. Thumbs up. You could figure out the A value, right? If I gave you a set of data like this. Okay, good. And then you know that the initial population is your K value. This is your growth rate, and this is the year. So what you've just done is you've written an equation that represents this data. Are we good on this? Okay, we're going to do it a lot. Okay, so if you're not 100%, if you're still a little this way, we're going to do it a lot before we leave today. Okay, now this example is to make sure you understand the difference between increasing and decreasing, and the difference between exponential and linear graphs. So take a minute and see if you can match up A, B, C, and D to 1 through 6 first. Let's see if you can just do the matching, and then we'll write a description for the other ones in a minute. Okay, so what do you guys think for A? A would be what? Which graph looks like it might be A?
2.
Is correct. So here's 2, and 2 is 5%. And this is exponential. Now, that would be this graph right here. Why, can you tell me, who was that, Ian?
Yeah.
Okay, Ian, can you tell me why you didn't choose, tell me why you didn't choose this one? Because this is exponential and increasing.
Because I saw the next one was 8%, so it'd be a little steeper than 5%.
Excellent, excellent. Yeah, that's exactly right. Right, so number one would be more like the answer to B, right? So we know that if it's increasing by a percentage, it's an exponential. If it's increasing by a flat rate, we know it's linear, right? Okay, so then what about C? How about somebody new? Do C for me.
Would it be 3?
It would be 3. So this is population increasing by $5,000 per year. Now, the only other graph that you could have chosen besides 3 that's linear would be 5 or 6. 5 is not increasing for sure, right? And 6 is decreasing. So you definitely don't want to choose that one. And which one would be the population was stable?
5.
5.
Yeah, definitely 5 because it's flat, right? And think about something that's stable, like a line that is flat, right? What is that 5? A line that's flat is a horizontal line on the coordinate plane, right? And remember, that's always equal to a number, no variable, right? So whatever x is, y is always going to be the same number. So that makes sense, right? This means that if a population is stable, it's not growing or decreasing, which means it would stay as the same number, whatever that number is. Does that make sense? Okay. All right, so now all we have to do is figure out how to describe 4. Well, let's get, I might as well use my colors here. So 4 would, how could you describe that? You guys tell me. Population does what?
It decreases.
Decreases by a certain percentage rate, right?
Yeah.
I don't know. Maybe let's just make something up, 8%. I think I said 8% because this was 8% growth and it looks to be similar, in steepness. Okay, so that's 4. And then the other one we had to do was 6. So that would be this one. So how would you describe that? Population does what? Increase or decrease?
Decrease.
So you don't want to say decrease by a percentage because it's linear, right? Decrease by a certain amount, right? Let's say 5,000 per year. All right, so that's pretty simple, right? Just recognizing whether it's exponential or linear is easy, and whether it's going up or down is easy, right? So just be careful if something's steeper than another one, so that like between 1 and 2, you know the difference there. Okay, now what we're going to do is, and what we just did right now is compare the graphs of exponential to the graphs of linear equations, right? And it seems like that's simple enough, right? Anybody have any questions so far? Okay. So now we're going to take a look at the actual function itself, like, the the formula. So back up here, we said in general, this is the formula. So all I'm doing is changing the f of x and the k to different letters so that it makes sense in terms of population. Most of our problems are population problems. So just like in the earlier one, this value was your initial value. This guy is your factor. Well, I don't need the word your, let's get rid of that. This is factor, which factor by which P will change. P changes for every increase of 1 in T. For every increase of 1 in T, or the time. Well, if we're looking at a linear, then this right here is always going to be your initial value. And this is going to be your constant change. Which is just slope. Okay, so now we're going to use that to write some equations. So why don't we do first of all, is A and B, are these linear or exponential situations? Anyone can answer.
Linear.
Yeah, thank you. They're linear, right? Because they're changing by a constant amount, right? They're saying increasing by 0.4 milligrams per minute. So every minute it changes by the same amount. So that's how we know these are linear. All right, so linear equation is going to start with y equals b plus mx. So let's see, what are we talking about here? The amount of adrenaline. Suppose the initial amount is 15 milligrams from a formula A. So that means replace the y value with A. Of course, we're in terms of time. A of t is equal to, what's the initial value here?
15.
Yeah, it's 15. 15, so that should be value, plus, what's the slope in this case?
Would it be 0.4?
Yeah, 0.4. And then we've got t, because we know that the amount of adrenaline is in terms of how much time goes by. Excellent. Okay, so the only difference between A and B is in A, it's increasing, right? So the slope is positive, which is why I did plus 0.4t. So how is the equation going to change if it's decreasing? What do you think? Well, again, we start out with y equals b plus mx. A of t equals, you guys tell me, what do you think?
Would it be 15 minus 0.42?
Yeah, good. 15 minus 0.4 t. Simple.
I have a question.
Yeah, go for it.
So for our homework, for like Wiley and stuff like that, would it prefer for us to write the A function, or do we have to write the y equals b plus mx?
For Wiley, they tell you how they want you to do it. They'll tell you, and they'll be very specific. You know what? I'm gonna make a note to double check that. but I will tell you in this problem, the clue that they want you to use A is because they're asking you to write a formula for A. You see that? And they want you to use T minutes, right? That's your clue, like, okay, they want it this way. Does that answer your question? But I will double check and then see if it's fuzzy or whatever on any of the problems. Okay, so now we're gonna start with P equals P, this is a sub-zero little thing, A to T. All right. So we're talking about adrenaline in terms of time. So of course we'd want to do that because here's the adrenaline, here's the time, right? So A in terms of time can be written like the P sub-zero is your initial amount. So how much was that? We found out in the last problem that your initial amount is 15, right? And then you're going to do, where's the formula? Here we go. And then in order to find the growth factor, we're going to take 1 and add 0.03 because they tell us that it's increasing by a percentage, and then just raise it to the T power. So this we can simplify to just A of T is 15, 1.03 to the T power. Now, the only difference here, again, we're going to use this same formula. A of T is going to equal 15. This time it's 1 minus 0.03 because it's decreasing. So you would get the final answer of 15, and then 1 minus 0.03 is 0.97 to the T power. Now, one little thing I want to just talk about for a second is that, remember, your A value is the factor, the growth factor. To get the, it's not called decay factor, it's just called growth factor. And then if, let's say I wanted to find a decay if given the growth factor let's say is 0.989. Well, to find the growth factor, what you'd have to do, no, sorry, given the growth, no, I don't mean to say growth, find decay, that's not what I mean to say, sorry. Let me start again. Find decay rate given growth factor, which is the A, is equal to 0.989. So what you'd have to do is just take 1 and subtract 0.989. And in this case, you would get 0.011, which is equal to 1.1%. Just a little side factor, just a little side note on how to find that. It's easy to find the growth rate if I give it to you as growth, right? If I say 1.03, what's the growth rate? Oh, you look at it, oh, it's 0.03, obviously, because that's how much more than 1 it is. Okay, moving on. All right, these are all true things, you know, by the way, these examples, they're all true statistics. So apparently wolves were once common in the Western US. By the 1990s, the wolf population in Wyoming had been wiped out by hunters, and wolves were put on the endangered species list. So in 1994, that seems important, wolves were reintroduced to Wyoming from Canada, starting with, that seems important, right? 14 wolves. Their number increased to 2007 in 2012. It all seems important, right? Assuming the Wyoming wolf population was growing exponentially, so they're telling you, yes, it does fit the exponential model. Find a function in the form P equals P sub 0 A to the T power, where P is the population, T years after 1994. So you're going to start with the formula. Then you're going to plug in what you know. So we know the initial population and we know the resulting population. The P is what the resulting population is, right? So what would that be? What number could we put in for that P?
Would it be 207?
Yes, it would. Thank you, Drew. 207. Okay, and P sub 0, that's the initial population. So what's that going to be?
Would it be 14?
It would be 14. Thank you. And then we've got this A value. And do we know anything about time? What's the total for when to get to 207 as a resulting population? How many years have to go by?
18.
Yeah, 18. And you got that how?
Difference between 1994 and 2012.
Right. So 2012 minus 1994 is 18 years. Okay, so we plug in what you know. Then you're going to solve for A. So let's see, let's use our color coding here. Divide both sides by 14. And you get 207 over 14 is equal to A to the 18th power. And we know we're going to put this in a calculator, so there's no reason for us to figure out what 207 over 14 is, because we're going to get decimals here. So instead, you're just going to save yourself some time. Use a calculator to take the 18th root of both sides. So let's see. I like, I'm using Desmos more and more these days. And it also will do a little bit more than a regular graphing calculator will. Like, you know how a regular graphing calculator, you have to solve for Y first before you can get a decent graph? On Desmos, you don't have to solve it for Y. You can just write it in as, you know, in standard form or whatever, and it'll graph it for you. So I really have been using Desmos a lot with my high school classes. I'm going to go to, you use the graphing calculator. Well, not graph, that's not what I wanted to use, never mind. I wanted to use the scientific calculator. So we could just write it in. Here you say function. I want the 18th root. So you just type, go back to the main, 18. I like this because it puts in like you mean it, right? So if you mean 207 divided by 14, and you mean for 207 over 14 to be under the radical sign, you don't have to worry about making sure that you have parentheses, right? So this does what you're asking it to do. So we're going to get 1.16 and so on. Now be careful. You have to watch Wiley, right? And make sure you're rounding to the decimal place they're asking you to. Okay. This back over here. So now our A value would be equal to 1.16. So if you take your A value and subtract 1, you would get 1.16 minus 1, or 0.16 is your growth rate. This is what we were looking for. So not the growth factor is 1.16. The growth rate is 0.16, or 16%. Any questions? Is this making sense? Everybody okay? All right. Okay. Okay. So here's an example where, and remember the 4 things. I can give you a problem using a table, using words, using a formula, or even a couple of points on the graph, which is exactly what we're doing here. This is something that might feel really brand new to you. So stay with me. So the first thing they want you to do in this example 4, they give you, suppose that Q is equal to f of t. That means a function f of t, and they're just calling it Q. It's kind of complicates it all, but whatever. So it's an x. They're telling you it is exponential. So yes, you can start with the equation. So first thing you're going to do is find the base, right, in order to answer this a question here. And you can do it by first writing equations for both points. So first you're going to write equations for both points. All right, so one equation could be that 91.4 is equal to whatever the initial value is. Notice they don't give you the initial value here, times the growth factor, and t, the t that goes with 91.4 is 23. Then let's write another equation for the other point. So that would just be 88. Oops, I want to use a different color. There we go. That would be 88.2 is equal to the initial value, a to the, how many years? 20 years. Okay, now the next step, what it has you doing is we're going to eliminate Q of 0, Q sub 0, so that we can find out what A is, right? Because we've got 2 variables that we don't know what they are. So what we're going to do is use this cool trick where what you can do is you can divide, since we know they're related to each other exponentially, we can take 91.4 equals Q sub 0, A to the 23rd, and we can just divide by the other exponential equation, which is 88.2 equals Q sub 0, A to the 20th power. The reason why we're doing this is so that we can eliminate Q sub 0, right? Because they're both the same initial value, because they're both on the exponential graph. So this cool trick, what it allows us to do is we're gonna, we will divide to eliminate Q sub 0. And remember too, that they're asking us to find the base. What they mean is the A value. Okay, so if we eliminate this, then what we can do is take 91.4 divided by 88.2. There's the equal sign from the problem. And now I have A to the 23rd over A to the 20th. So I know I can simplify the left side, right? Can I simplify the right side? This is where algebra 1 comes in.
Is it just a to the third?
Yeah, it's A to the 3rd. Thanks, Dylan, right? You're just using your exponential rules for division. So we can say that 91.4 over 88.2 is equal to A to the 3rd, right? Because just 23 minus 20. You use the quotient rule, you're going to subtract exponents. And then in order to get A by itself, I'm just going to do the same thing that I did up here, right? Where I had something to the 18th power, took the 18th root of both sides, which I can do with a calculator. So now I'm just going to take the cube root of both. That's not enough. I want a different color so you can really see what I'm doing here. There we go. So now I'm just going to take the cube root of both sides to get A is equal to 1.012. So we just found the base. So that's the answer to A. What's the percent growth? You can kind of just, by looking at the growth factor, you can figure out what the growth rate is. What is it?
1.2.
Yeah, 1.2%, right? So it would just be, remember, whatever the A value is minus 1. So we've got 1.012 minus 1. You obviously don't have to show this work. I'm just trying to get you to mentally go there. 0.012, which is equal to 1.2%. I'm just waiting for you guys to catch up. I see a couple of people still writing. How come you all have your what am I thinking? Your video off? I thought we agreed it was better if your video was on so I can see if you're confused or raising your hand or whatever. Thank you. There we go. I mean, I don't mind if, like, you know, you turn off your camera for a minute because you have to do something or whatever. That's fine, but I'd rather be keeping it on. All right, any questions so far? All right. So now we're going to evaluate f of 25. So we're going to find q sub 0 by substituting what we know. Okay, so we start with the formula. P equals q sub 0 a to the t power. We're going to just, we can just use 1 point for this part. We've got 88.2 is equal to q sub 0. I'm just using one of those points above. But now we know what the growth rate is, right? So we can plug that in. Not growth rate, sorry, growth factor, 1.012. And the number of years that goes with that 88.2 number is 20 years. And I could have used the other point too, it doesn't matter. Now from here, I'm just going to solve for Q sub 0. So what I can do is divide both sides by that number, 1.012 to the 20th power. It's just a number, right? Divide this side by the same thing. That will cancel out and isolate Q sub 0. So if you put this in your calculator, you get that Q sub 0, or the initial value, is 69.5. Okay, so we found Q sub 0 by substituting what we know. So now we can write an equation that is complete. So we can say that we've got Q is equal to Q sub 0, a to the t power. Q is equal to 69.5 times 1.012 to the t power. So now we can say, what is f of 25? Or I wonder if we should have been using f. Is there anything in this that said Q is f of t? Okay, yeah, maybe we should have been using f. I'll change that in the notes. So really, but Q is f of t, so it's not wrong to say this, but maybe final answer should be f of t is equal to 69.5, 1.012 t. And now to find f of 25, we're just going to put 25 in for t. So if you did that, you would get 93.6. I'm just trying to give you guys enough time to write. Any questions about this so far? No. All right. Okay, it says a 50 milligram dose of quinine is given to a patient to prevent malaria. Quinine leaves the body at a rate of 6% per hour. When you're doing these problems, I want you to think, first thing I want you to think of is this increasing or decreasing? What is it, you guys? Obviously, by the graph, it is.
Decrease.
Decrease.
Thank you. Okay. All right. So first, to find the formula, we're going to start with the formula. So the formula is. So the formula is P equals P sub 0 a to the t power. All right, so we're going to fill in what we know. Well, first of all, we know that I'm just double checking. Yeah, so here it says find a formula for the amount A in terms of T. So that's when you take your general formula and switch it to the formula that they want you to use. So this is A of T is equal to the initial amount. Do we know the initial amount?
50 milligrams.
Yeah, definitely, right? So we've got 50 times, they tell us the rate here, right? So the rate is always going to be equal to the rate plus 1. So it would be 1 plus 0.06 to the t power. Oh, sorry, I'm wrong about that. It would be minus, right? Because this is decreasing. So 1 minus 0.06 to the t power. And then you just simplify that. A of t is 50 times 0.94 to the t power. So that's find a formula. Then in question B, they're asking you how much quinine is in the body after 24 hours. What are they asking you to find?
When T is 24.
So how do you say that? A of,
24.
yeah, there you go. And that's what A of 24 would be. So question C is already done for you, right? So we already have this for you. But question D says use the graph to estimate when 5 milligrams of quinine remains. So this is time. And this is what we're interested in, right? The 5 milligrams. So we would want this number on the graph that corresponds with this time right here. So let's see, if that's 20 and 40, we could say that's 30. And then between 30 and 40 would be like 35. So you could guess like 37, right? So when the time is 37 hours, you'd have 5 milligrams. So to answer this question, estimate when 5 milligrams of quinine remains, you would say about 37 hours. Any questions on that one? Okay, now here's one for you to try. Now what I want you to do, you guys have notes, I assume. What I want you to do is look at this next example and tell me which example it is most like. Is it most like example 5? Most like example 4? Most like example 3? Or most like example 2? Okay, so I'm gonna show you the next example and you're gonna tell me what is this most like? This is what you're going to have to do when you do your Wiley problems. You're going to have to say, okay, so out of all the examples Miss A did for us, I would do this problem like which one of these examples, right? You're going to have to be able to do that. You guys tell me.
Is it like example 1?
Example 1. Was a table of function, well, no, that wasn't it. I'm looking at the wrong one. No, example 1 was looking at graphs and telling whether it's exponential or, did you mean that one?
No, it was the one where we did the 2008 and 2007. Was that the wolf one? I didn't really write it down.
Oh, okay. Well, no, the 2008, 2007 was just population growth wasn't even an example. It was just to show you that it was exponential. But I appreciate you being willing to go out there. It's safe, right? So I really do appreciate you at least being willing to guess, right? Rather than not even being willing to guess. So, and that's I guess that's fair. But anybody have any idea before I tell you?
Was it example 3? Was it like the wolves, the 2 time periods, and then
Let me see. Not really. What I'm looking for you to understand, well, actually, you could say it was like either one of those, yes. But really, this is more like example 4. So it's like example 4 because basically I'm giving you 2 points, right? 2 points. And if you look back at example 4, it says, suppose that Q is, no, sorry. So it says if f of 20 is 88.2 and f of 23 is 91.4, find basically an equation, right? So what we're going to do in this example is it's very similar to example 4. Okay, so what I'm going to do is first start with the formula. P equals P sub 0 a to the t power. And I'm going to write 2 different equations, right? One equation for 1 point. So for this set of data, I can write 5.15 is equal to P sub 0 a to the, let's say 66 power. And I'm getting 66 from 2004 minus 1938. And then the other equation I can write based on the other point is 0.25 is equal to P sub 0 a to the 0 power. And this would be years, let's go do this, since 1938. So that's where I'm getting that. Years since 1938 would be the time. Okay, so I'm using each point I gave you to make up 2 separate equations. And then what I'm going to do is I'm just going to use division of those 2. Let me write before I forget here. So I'm going to take 5.15 equals P sub 0 a 66 and divide it by the other equation, 0.25 equals P sub 0 a to the 0 power. So that's the same thing as just saying 5.15 divided by 0.25, these cancel out, is equal to a to the 66 minus 0 power. Let me write that legibly. Which is just a to the 66th power, right? And then what are we going to do to solve that to both sides? Yeah, go ahead, Dylan.
Take the square root of 66 from both sides.
Yeah, the 66th root, right? And you can do that using Desmos too. Another thing that you could have done is raise it to the 1/66 power. It's the same thing mathematically speaking. So you would just get A is equal to 1.0469. So your growth rate of this, so the growth rate of minimum wage is 4.69%, right? So yes, you can say that inflation, you can say that minimum wage has, yes, indeed, kept pace with inflation. And that's because 4.69 is even a bigger growth rate than the inflation rate, which is 4.3%. So I would say yes, and then some, right? And let's make sure. Presidential debates questioned whether the minimum wage has kept pace with inflation. So since the growth rate was more than the rate of inflation, 4.69% is more than 4.3%. So you can say, yeah, it has kept pace. Any other questions? All right, your assignment is up on Wiley. And I will also post, you're probably looking for the videos of these. And I just keep forgetting to post those. So I'm not going to leave this desk until I've posted them. It will take a little while for this one because it takes a long time for it to like digitize or whatever. So I'll post them all today though, in the right places. Thanks, guys.
Yeah.
Have a great day.
Thank you.
Thank you.
Bye.
I have a
Have a
question.
good day, Professor.
Where'd you go? Hang on. Yes, Sophia.
Oh, okay. On Wiley, it said like the homework's 1.5 to 1.7, right?
Yeah.
When are we doing 1 point, like one of the sections, like are we taking notes ourselves or are we doing like 2 sections in one class? Because it said it was due on Thursday, the homework.
Oh, it does?
Yeah.
Oh, yeah. Next class, we're going to do 2 sections.
Oh, okay, cool. That's
Yeah.
that's all I was
Yeah.
saying. Okay.
But you
thank
can always start it, right? And then,
Yeah, like start this section and then do the other 2 sections.
right. That's what I would suggest.
Yeah, that's probably what I'll do. Okay. Thank you.
Okay. Thanks, Sophia. Connor, you have a question?
Yeah, I do have a question. I've been having issues. Had issues with Wiley earlier, and I've already contacted them twice. Today was the 3rd time. I did it during class. I'm sorry about that, but
That's okay.
I finally got it working now, because
Okay.
apparently the first 2 times, one, it said my account didn't exist, and then we got it working, and then I got into your class. I'm registered, but then the second time, like, was your class wasn't showing up, and it was apparently the guy who put in my, like, who had to register for me.
Mm-hmm.
He only did it for like a week, so after a week it just vanished.
Well, yeah,
So-
because you have to pay for it.
Yeah, but see, I already paid for the access.
Oh, gosh, what a pain.
Yeah, so I just got it working today. So I've not finished the first homework. Is that still able to turn in, or?
You know what, while you still are on the line, I think that I can open it up just for you without opening it up for the whole class. Let me just double check. I believe I can do that, but let me check, okay?
Okay. I'm sorry, it's been a bit of a hassle.
Let's see.
Sorry about this. It's been a bit problematic.
Yeah, and I had this same issue came up last year with somebody else who had Wiley in the past. Why did this just timed out?
We have first string type, we have like what we would look for and how we.
Because finally I can at least log in now and actually like access the stuff.
Right.
I guess you can go there, but I don't know if you're gonna.
Ah,
If it's not possible, it's okay.
yeah, I'm pretty sure I can do it. But I'm just having issues right now with Wiley. Okay, wait. Ugh. Mm. I'm gonna have to get back to you. I'm sorry. My computer is timing out with Wiley. So I will just go ahead and start today's assignment, and I'll email you and let you know, or you'll just notice that it'll be open. I know I can do it. I just have to figure out how to get back into Wiley. All right.
Yeah, thank you, Miss Alderman.
You're welcome. I'm pretty sure I can do it.
All right, have a good day.
Thank you. You too.